Hello guys, welcome again to my channel. Today we want to solve a nice maths challenge which read x to the power of 3x to the power of 6 is equals to 16. What then is the possible value for x? So please, if you are new here, kindly subscribe, and by the time you subscribe, please don't forget to turn on the notification button so that you'll get notified whenever I drop videos of mathematics. So let's see how I can solve this. Okay, having this, we can say s to the power of 3x or to the power of 6 equals to 16. So the next thing I can do is to multiply both sides of the equation with the natural log value. So I'm going to do ln of x to the power of 3x or to the power of 6 is equals to ln 16. So the next step, recall, if you're having something like this is going to the back. So recall from the principle of logarithm, which if you're having ln a to b, is also equals to b ln a. So if we should succumb to this rule here, we have this to be 3x to the power of 6 ln x is equals to ln 16. Okay, having done this, what are we simply going to do? Okay, having done this, the next thing we can do, let's say we are going to equate ln s to be another value. So we can say let ln x equals to b. Let ln x equals to b and x equals to exponential b. Let ln x equals to b and x equals to exponential b. So if we should succumb to this rule, we are going to have 3 times exponential 6b times b equals to ln 16. Okay, having done this, what then is the next step? So the next step is to divide both sides of the equation by 3. So if we should do that, we have exponential 6b times b is equals to ln 16 divide by 3. So because we said we want to divide, we'll divide both sides by 3. So if we should divide both sides by 3, we are having exponential 6b times b is equals to ln 16 over 3. So we can write this to be b times exponential 6b is equals to ln 16 divided by 3. Okay, so this is what we're now having. What we just did, we just interchange by putting b here times exponential 6b is equals to ln 16 over 3. So at this junction, we want to apply the Lambert W function. The Lambert W function is a rule we actually use when an exponent is involved. So what does the Lambert W function says? It says if you're having star exponential star, and if we should take the Lambert W function of it, is equals to star. So if you take star exponential star, we take the Lambert W function of it is equals to star. We are using star. Let's represent star. Okay. So this is what the Lambert W function says. So if you look at this equation very well, the exponent is different from this. So what are we going to do in order for us to make the exponent or this to look alike with the exponent? We are going to multiply both sides of these equations by 6. So if you do that, we have this to be 6b times exponential 6b equals to ln 16 over 3 times 6, because this 6 will cancel off this 6 and will return back to the whole of this. So having done this, what then is the next? So we can see that we are having 6 here, we are having 3 here. So we can say 3 here is going to give us 1, 3 here is going to give us what? 2. So if we write this, we are having this to be 6b times exponential 6b equals to, so these two we can write it at the back, becoming 2 ln 16. So we are now having 6b exponential 6b is equals to 2 ln 16. So what then is the next step? Let's move. Okay, since we are now having 6b exponential 6b is equals to 2 ln 16, we can write 16 again. Recall 16 is also equals to 4 square. In other words, also equals to 4 times 4. So 16 is equals to 4 square is equals to 4 times 4. So we can say 6b exponential 6b is equals to 2 ln 4 square. I recall this will be going to the back, right? From the basic rule which says we are having ln a to b is also equals to b ln a. Okay, so if we should succumb to this rule here, we have this to be 6b exponential 6b is equals to 2 times 2 ln 4. Okay, so we're now having 6b exponential 6b is equals to 4 ln 4. 4 ln 4. So why are we doing this? Why are we doing this? We want to apply the Lambert W function in both sides. Recall, we can simply apply the Lambert W function here now to solve this, but now we also want to apply the Lambert W function here also. So look at what I'm solving. So 4 is equals to exponential ln 4, because this exponent will cancel this ln. So my 4 is equals to exponent ln 4. So if I should do this, I'm having 6b exponential 6b is equals to, so in the place of 4 I can put exponent ln 4. So I'm saying exponent ln 4 times ln 4. Okay, so I can write this to be 6b exponent 6b is equals to, so I can write the whole of this to be ln 4 times exponent ln 4. Okay, so now I cannot apply the Lambert W function on both sides. Recall, the Lambert W function says if we are having star exponential star, if we should take the Lambert W function of it is equals to star. So we are having 6b exponential 6b equals to ln 4 exponential ln 4. So if we should take the Lambert W function of it, Lambert W function of 6b exponential 6b equals to Lambert W function of ln 4 exponential ln 4, we are going to arrive at 6b is equals to ln 4. 6b equals to ln 4. 6b is equals to ln 4. So having done this, we can say our b is equals to ln 4 divided by 6. ln 4 divided by 6. Therefore, we can say our b is equals to ln of 2 to the power of 2 over 6. So having done this, so we can say b is equals to 2 ln 2 over 6. So having this now, let's solve further. Because we're now having b is equals to 2 ln 2 over 6, we can cancel also. Therefore, our b is equals to ln 2 over 3. Okay, recall that b is equals to ln x. Okay, so therefore wherever we see b, we can put ln x. So we can say ln x is equals to ln 2 over 3. Okay, having done this, or we want to look for x. So if we want to look for x, we can take both equations to the exponent. So if we do that, we would have this to be exponent of ln x is equals to exponent of ln 2 over 3. Okay, over 3. Okay, now we have to note something here. We have to note something here. So this and this will go. So we are now having x is equals to exponent of ln 2 over 3. So this is the value for x. But if we should solve further, note something here now. Note something here. Recall if you are having a to the power of b over c is also equals to a to the power of b or to the power of 1 over c. So if we should put this principle here, we can say our x is equals to exponent of ln 2 or to the power of 1 over 3. So having done this, this exponent will cancel off this ln. So we are having x is equals to 2 or to the power of 1 over 3. Therefore, our x is equals to cube root of 2. So this is the value for x. Okay, since we solve for x, we said x is equals to cube root of 2. So we want to substitute the value of x into our question to see what is going to give us 16. To give us this is our question, which is x to the power of 3x to the power of 6 is equals to 16. So we want to substitute the whole value into this to see what is going to be equals to 16. So let's do that. So note, my x is also equals to 2 or to the power of 1 over 3. So I can write this to be this. So if I should substitute this into this equation, I'm going to have 2 to the power of 1 over 3 times this 3 itself times this 3 times this again, which is 2 to the power of 1 over 3 times this to the power of 6 equals to 16. So we don't know. So having done this, so this and this will go. So we're having this to be 2 or to the power of 1 over 3 times what? So this and this will go, right? So we are left with these 2. So we're having 2 here. We're having 2 here. 2. We're having 2 there. Okay? So because this and this will go, we are now left with this 2. Then this 3 will cancel this. So 3 divided by 6. 6 divided by 3 is going to give us 2, or to the power of 2 is equals to 16. So we are now having 2 to the power of 2 to the power of 2 equals to 16. Okay? So we are having 2 to the power of 2 to the power of 2. And 2 to the power of 2 is going to give us 4. So we are having 2 to the power of 4 is equals to 16. And we say 2 to the power of 4 is likely to equals to 2 to the power of 4 is equals to 2 times 2 times 2 times 2. 2 into 4 places. So we are having 2 times 2 is going to give us 4. 4 times 2 is going to give us 8. And 8 times 2 is going to give us 16. Therefore, my 16 is equals to 16. In other words, the value of x in this challenge is correct. So please, if you are new here and you have not subscribed, do well to subscribe and turn on the notification button so that you get notified whenever I drop videos on mathematics. God bless you. Jesus loves you. Bye for now and see you in my subsequent video. Bye bye.